All right, 5.4, we're moving into polynomial division. And the one thing we do at the end here is really, really, really important. The other thing is a mathematical concept that we're going to look at. It's not as important as what we're doing at the end, but it is something, algebra, that you should be able to do. So I'm going to talk about long division. And I don't know how many of you, if any of you remember how to do long division, but there's a problem set up like this. And we look at it and we ask myself, okay, can 52 go into 37? And the answer to that is no. So then I ask myself, how many times can 52 go into 375? Okay, and I can put 52 into 375 7 times. Now, it doesn't go in evenly, so I put a 7 up here, and I multiply 7 times 52, and it gives me 364. I subtract, and that gives me 11. Okay, so I ask myself, and this shouldn't be able to, but can 52 go into 11? No. So then I drop the next number, which would be the 2, and I ask myself, how many times can 52 go into 112 without going over? And that answer is 2. 2 times 52 is 104. I subtract, and I get 8. I drop the next number, which is 5. How many times can 52 go into 85? And that's once. 1 times 52 is 52. I subtract. I get 3. This number here is called my remainder, okay? So I put my remainder, and we used to go something like this, remainder 33, or we could go 721 and 33 over 52. Okay, so plus 33 over 52. The 33 is my remainder, and the 52 is the number that we divided by. Okay, so for polynomial long division, it's somewhat like that, but again, we got to make sure we know how to set this up. Okay, so I'm actually going to start with an easier problem just to show you, okay, which would be x plus 5, okay, and I want to divide x squared plus 13x plus 40. So I want to divide these two polynomials. So here's how I do this. I ask myself, what can I multiply the first term on the outside by to get the first term on the inside? Okay, and I'm going to leave a blank here and a blank here. Okay, what can I multiply the first term on the outside? Well, what is the first term? The first term on the outside is x. Okay, so what can I multiply by x to get the first term on the inside? So what can I multiply by x to get x squared? Okay, so hopefully we know that that is an x, and I'm going to line this up over top of the x term. So I would have x times x. So now, once I find that, that is the key, what number can I multiply by the first term on the outside to equal the first term on the inside? And in this case, it's x. So now I'm going to take this x and I'm going to multiply, okay, x times x is going to give me x squared. The first thing I write down better be the same, okay? I'm going to take this x times x and multiply that by a 5. So that would give me a plus 5x, okay? So again, I'm taking that number. Once I establish what this number is, I'm going to multiply it by both of the terms on the outside. These two should always be the same, okay? Now, really important, I'm going to subtract, which means I'm going to change all signs. So this was a positive. I'm going to make this a minus, and I'm going to make this a minus. Okay, so I'm going to add down. The x squareds cancel. I've got 13x minus 5x, which is 8x. I'm going to drop the next term. Okay, I do the whole thing over again. I ask myself, what can I multiply by x so that it equals the first term on the inside? So this canceled. I'm now looking at this term. What can I multiply by x so that it equals 8x? And that would be an 8. Okay, so I multiply 8 times x. It gives me 8x. I multiply 8 times 5. It gives me 40. I change the sign. So I'm subtracting every time, so I'm going to change the sign. So that's going to be a minus, that's going to be a minus, and when I add down, both of these cancel. So when I divide x squared plus 13x plus 40 by x plus 5, I get x plus 8, no remainder. Okay, so that is my answer. Let's take a look at another example. And again, I'm going to write out what I just said. This is what I'm asking myself throughout every problem. What number can I multiply by the first term on the outside? And that is whatever is on the outside of the division, okay, to equal the term on the inside. This is going to change throughout the problem. So let's look at this next problem. I'm going to set it up. I want to take 3x squared minus 2x plus 2x minus 5 and divide that by x minus 2. So I've got an x minus 2 on the outside. I want to divide that by 3x squared minus 2x squared plus 2x minus 5. Okay, so now I want to ask myself this question. What number can I multiply by the first term on the outside? What's the first term on the outside? Well, it's x. Okay, so it's x. So I'm going to fill this in. To equal the first term on the inside, well, what's the first term on the inside? 3x squared. So what can I multiply by x to equal a 3x cubed? Right, that is a cubed, yeah. So what can I multiply by x to equal 3x cubed? And the answer to that is a 3x squared, right? 3x squared times x is 3x cubed. 3x squared times negative 2 is a minus 6x squared. So I'm going to change the signs. Okay, really important here. Change the signs. Okay, because I need that first term to cancel. So when I do that, that cancels. It gives me a 4x squared. I'm going to drop the next term, okay, which is a plus 2x. So now I go back to this. This will never change once you start the problem. What number can I multiply by the first term on the outside, which is x, to equal the term on the inside? This now changes. It's no longer 3x squared. Okay, it's no longer 3x squared. It's what? It's no longer 3x squared. It's 4x squared. Okay, I keep saying squared. That was cubed. Okay, so now it's 4x squared. So what can I multiply by x to equal 4x squared? And that answer would be 4x. So I put a 4x here. Okay, and then again, I multiply. What's 4x times x? It better be this first term, and it is. What's 4x times negative 2? A minus 8x. I change the signs. So that's a minus, that's a plus. I'm going to add down. That cancels. It should always. This is a 10x. I'm going to drop the last term, which is a minus 5. Okay, so now I'm going to ask myself again, going back to this, what can I multiply by x to equal, what's that last term? 10x. What can I multiply to equal 10x? What can I multiply by x? And the answer to that is 10. So I'm going to put a plus 10 here. 10 times x is 10x. 10 times negative 2 is minus 20. I'm going to change the signs. That's a minus, that's a plus, and I'm left with a 15. This is my remainder. So I write my answer as plus 15 over, what did I divide by? X minus 2. Okay, so this is what I was saying is this isn't the most important stuff, but it is used a little bit later on in chapter 8. So I wanted to make sure that I showed it to you. And it really goes back to this question. What number can I multiply by the first term on the outside? When I say first term on the outside, I'm talking about whatever this is, okay, to equal the first term on the inside. That first term on the inside is going to change at each step. And that is how I get these numbers up here. Okay, I got a 3x squared because 3x squared times x is 3x cubed. I got a 4x because 4x times x is 4x squared. And I got a 10 here because 10 times x is a 10x. So we've got to make sure that we're able to get those numbers, and I think that's the hardest part. Now I'm going to show you the easier way to do this. We have something that's called synthetic division. Okay, and synthetic division is really just being able to set it up. And then the math is adding, multiplying, adding, and it gives us the same result, and I think it's much, much, much easier. Okay, so the setup goes like this. Whatever I'm dividing by, I put the opposite. Okay, so I'm dividing by x minus 2. The opposite of minus 2 is plus 2. So I put the opposite of the factor. Okay, and then I'm going to write like a little upside down half of a rectangle. And I'm going to put the coefficient of everything that I'm dividing by. So I'm going to put all of these coefficients with their sign in this problem and leave myself some space to write underneath. So I've got a 3, a -2, a 2, and a -5. Okay, so the first thing that I do is I drop the first term. I'm going to put a 3 here. Anytime it goes diagonal, I multiply. Okay, 2 times 3 is 6. I'm going to put that right underneath the next number. Anytime I go vertical or up or down, I just add. Okay, so -2 plus 6 is 4. 2 times 4 is 8. Diagonal, so I multiplied. I add down. 2 plus 8 is 10. 2 times 10 is 20. I add down, which is 15. Now, here's the important part. Being able to do this process, I think, is easier because anytime I'm diagonal, I multiply, and I put these numbers up here. Anytime I go straight up and down, I'm just adding. This number here is always my remainder. Okay? This number here is always my constant. This number here is always my x term. And this number here is always my x squared term. So to write this out, these are the coefficients of each one of these numbers. This would be 3x squared plus 4x plus 10 plus my remainder, which is 15 over, what did I divide by, x minus 2. So this is kind of a mathematical shortcut to dividing. Again, where did I get this 2 from? It's the opposite of whatever I'm dividing by. And then all of these numbers are the coefficients from the original problem that I'm getting, that's inside the division sign that I'm dividing by. Okay, so and then I just, anytime I'm diagonal, I multiply. Anytime I'm straight up and down, I add. But the key is to drop that first number. This is called synthetic division. It's really important because of what we're about to talk about. Is anytime, if I get a remainder of 0, that means whatever I divided by is a factor. Let's take a look at this again, and this is basically what it is saying. Okay. Now, we can only do this with linear factors. So I've got a polynomial here that says, what are the dimensions of the box? I want you to use synthetic division. So I've got an x plus 5 here, and here's what I'm dividing by. So what would go on the outside? A -5. What goes on the inside? Again, why is it a -5? Because it's the opposite of the factor. So I've got a 1. That's the coefficient of the first term. A 7. A -38. And a -240. I drop the first term. I multiply. I add down. I multiply. I add down. Okay, -5 times -48 is positive 240, which means I have a remainder of 0. So I'm left with x squared plus 2x minus 48. There's no remainder, so I don't need to write that. So now this is asking, what are the other 2 dimensions of the box? And I'm left with a quadratic that I can factor. So I would be able to factor this to x plus 8, x minus 6. There's the other 2 dimensions of that box using synthetic division. Okay, so understand 2 things. If I do synthetic division and I get a remainder of 0, that means that this, whatever I divided by, is a factor, and whatever my answer is also a factor. So we're going to use synthetic division a lot over this next couple of days. So there's a problem that looks like this. It says to factor this. I can't do grouping. It won't work. Even though there's 4 terms, when I group, I don't get the same thing. But I am telling you that f of -3 is equal to 0. means that this is a 0. If I give you a 0 to write a factor, we always just put an X in front and change the sign. So what I'm saying is this is a 0, so I use the same exact number that's given, and I'm going to do synthetic division. Okay, again, the setup. Where'd the -3 come from? Because I told you that's a 0. It was given as a 0, not a factor. So I break every coefficient here. I drop the first term. I multiply. I add down. I multiply. I add down. I multiply. I add down. This tells me right now that this is indeed a factor and a 0 because I got a remainder of 0. And that leaves me with a what? This is my remainder, my constant, my x, and my x squared. So I'm left with 2x squared plus 5x plus 3. Don't need to worry about the remainder because it's equal to 0. Now we need to remember how to factor this to answer the question. Okay, remember I do a times c up here, which is 2 times 3, which is 6x squared. Bx goes down there. And then what two numbers multiply to 6 and add to 5? Well, that would be 3 and 2, right? And then I'm going to divide by the a. Okay, so this would be put the denominator, put an x after it, add or subtract the numerator. This is how I showed it back in chapter 4. We've got to make sure we reduce this. I take the denominator, put an x after it, add or subtract the numerator. So this would be the other two factors for that problem. Okay. There can definitely be some confusion in this section, but it's just a lot of synthetic division and long division. So understand that when we're looking at these problems, I don't want to go here. Let's end this. These problems for Delta Math are all synthetic division and long division.